start off as always with looking at our DMs. Let's go from the bottom up. Okay, so this person, it was just rearranging this equation for y. And I wrote an answer, but I think I explained it poorly and they misunderstood. Because they were asking if they should divide by 4y rather than just 4. And so I tried to explain it a bit more clearly for why we only divide by 4. And then they said, so does it work in the same way as when you want to add or subtract number by both sides? Oh, so I guess maybe their confusion is about flipping the sign to the same way you have to flip the sign when you add or subtract from both sides. I don't think this person answered it. I didn't answer it in the way that I would. So let me write my version of this. So I think I see the issue. Actually, is there a point in saying that? Let me just see. I should just say what it is rather than just saying I think I see the issue. Need to flip the sign when we multiply or divide. Actually, no, let me not, okay. The positive 4 comes from the 4y, as you said. All we need to do is divide by 4. We don't need to flip the sign or do anything extra. For y is multiplication 4 and y, so we divide, so the inverse. So I shouldn't say, I mean, inverse is probably a dangerous word to use. So we undo or invert that multiplication by dividing by 4. It can be confusing since when we undo addition or subtraction, we're basically flipping the sign. But that's unnecessary. It's 2 ends or 1 end? Unnecessary. No, it's 2 ends. Multiplication and division. I think that's their real things. I think they're interpreting adding and subtracting both sides as flipping the sign of whatever's there. And I think they're doing that same sign flipping for multiplication and division. And so just trying to explain it to them in the terms that they currently understand. I think this is the best way to say it. I hope. Okay, so let's look at the next DM. Oh, okay, they're just saying thanks on this one. Oh, they deleted their question. Oh well. They just made it, that's about the best the best price that a company should sell its like teddy bears at. And it's made a simple error at the very end that was corrected. So let's look at this one. Seems to be too simple of an answer. Class using graphs and inequalities to solve these types of questions. Eh. Okay, so I remember this one. It was not actually another price well, not price optimization, but it's a very weird question that I did not like. Basically about a snack bar that sells hamburgers and hot dogs. They make more profit on hamburgers, but they can only sell up to 90 things total. And so I said, well, I mean, just sell as many hamburgers as you possibly can, and then do the rest as hot dogs. It's just weird. I mean, you can make inequalities represent this. It just seems weird. I'm just gonna leave that. I mean, it just seems unnecessary to have to make an inequality for this. It just the question is super weird. I'm just gonna leave it alone. But let's go and do the usual rounds through the subreddits. X to the 4 over 4. Oh, 1/4 X. So it's 1/4 times X to the 4th. Okay, I wish they had gotten the formatting right, but at least they explained it. So yeah, they derived that and they got the right thing for the derivative. X minus 1 squared equals 0 and x plus 1 equals 0, giving 1 and negative 1. Let's take this and plug it into Wolfram. Just see if they got the roots right. One and negative 1, good. They get negative numbers from negative infinity up to negative 1. Positive for negative 1 to 1, and then positive again. Positive, then negative, then positive again. So I agree with the answer that they got. Let's look at the quartic function and see if that does match. Because if it does match, then I guess there's a typo on um, the answer that person is looking at. Wait, there were minus signs here, weren't there? Yeah. So yeah, decreasing up until negative 1. Really? Wait, no, increasing and then increasing still. No, yeah. Because they say, the book says, that can't be possible. The book says it's increasing up to negative 1, which is, it's decreasing. And then so the book says it's increasing on this, and then it's decreasing, and then it's increasing it. So it only got the very last one right by coincidence, probably. It's weird. there is an error in the I guess I'll say provided answer or book answer, I guess. Answer is U, and even plot the original vertex function to see that it's increasing, oh, sorry, decreasing, the opposite, up until x equals -1, then increasing way through after that. Okay. I don't know, dude. This just feels a little too much like someone wants to do their homework. Someone wants someone to do their homework for them. I have a new DM. Hey, Jed. You wouldn't take the square root of that. You plug the number into the entire thing. Wait. If you plug 0 into this, you do get positive. This derivative is equal to x minus 1 squared times x plus 1. One term will always be positive. The other term is only negative when x is less than -1. What you're saying is correct for finding the roots of x cubed minus x squared minus x plus 1, where you would set it equal to 0 and factor it to get x plus or x minus 1 squared times x plus 1 equal 0. But once you've found the roots, you can't just square root the x minus 1 squared in the original function. Well, this is explained poorly. Only taking the square root of x minus 1 squared for the sake of finding the root. You can't just do it when plugging in numbers to find values of the function. Um, you're right that x minus 1 squared is always positive, so the entire f prime x function is only negative when x plus 1 is negative, which is why I think the book answer is wrong. Okay. Hopefully that helps. This person just seems to be taking the square root just to force it to match the book answer, but you're not allowed to do that. How do I solve x over 2e times e to the ln e plus ln e plus 1 minus x ln... It's not equal to anything. I just need to simplify it? This is such a weird question just to... Like, I feel like this is designed just to, like, confuse people, and you never actually need to do stuff this complex. I mean, I guess sometimes you do end up with weird ln's and stuff with in calculus problems, but, like, this is just strange. Um... So ln e is 1. ln of e plus 1, that's... You can't simplify that directly. You need to, like, split this up into e to the ln e plus 1. And you'll get e plus 1 down below. They seem to have done that without saying it. Let's just try it for ourselves and see how it looks, then hopefully we can help them out with it after. So I'm interpreting the question as x over 2e e to the ln e plus ln e plus 1 minus x e to the ln e over 2e. I don't know why this is a question, but I definitely want to split up this plus into two separate e's multiplied together. I'm writing this into one fraction too. Over 2e minus. So all I did is I split that plus up into two separate multiplications, which is an exponent rule. Over here, ln of e is just 1. So we get x to the e over 2e. E to the 1 is just e. So here we can do the same thing with the ln e. There, the e and the ln basically cancel, so we get e plus 1 over 2e minus them. We can cancel the e's to get x over... Well, we don't want to cancel the e's, right? We want to get everything to one fraction. Actually, no. Okay, fine. I'll just rewrite that as is, because on this next step, we'll cancel the e on the left side too. Hey, hard luck. Fractions are fun. This one is just kind of a pain. Okay, then we can cancel the e from there, and we cancel the e from here and here, and combine them into one fraction because they just have 2 on the bottom. So x e plus 1 minus x over 2. I mean, there's not that much else you can do with this. We can multiply in the x. xe plus x minus x. Oh, I guess there's more that you can do because you get x minus x xe over 2. Actually, you should be writing ex instead of xe. I don't know why Crumbles pronounced them as xe. Hey, here, Ben. So they got, this is as far as they got. X over 2e, e squared plus e. So I think I did it in a different way. I think they're basically at this step, but they multiplied the e inside there. And I mean, what's the best way to... I think they need to cancel the e's on the top and bottom. Um, for cancellations for e on the top and bottom of each fraction. And they write x as a capital, which even weirds me out more, but I'm just going to match how they've presented it. What's up, Jed? How should I write this? X e squared plus e. I keep running c over 2e. Dang it, you're right. It's a good question. I'll keep my work shown in case on the denominators you combine the numerators first. You could combine the numerators. I don't know which one is simpler to show though. I was thinking keep them separate because the cancellations are easier to see when the numerator is simpler. But you could also combine the numerators. I just think it's simpler to explain keeping them separate though. X e plus 1 over 2e equal to x e plus 1 over 2. Okay. In the second fraction. Oh, you would get that same plus and minus xe. I guess you're right. Hmm. All right. Yeah. Let's say that way. Combining the two fractions, since they have a... Oh, you actually still can't see in everything that I'm typing, can you? There we go. Hey, e to the 2 pi, it's pretty good. How about you? Common denominator. Of 2e. You would get x e squared plus e minus xe. It's been good. I've been able to relax a bit today. Oh, nice. Glad to hear that. Over 2e. Yeah, the math is good. We've had some good questions this week in class, so I can't really complain about it. From there, oops, if I'm writing capital X, I should be consistent about it. From there, I would multiply things out on the top and look for more simplifications and cancellations. I mean, a cancellation is a simplification, but I just want to explicitly say that I think cancellations. Okay. Very weird question, but it's what they have, so. Let's look for a new one. Let me expand out my browser. Oh, this person is being active and getting back to me. So they had, basically this one, they're given this quartic function. Oh, they fixed the formatting. They derived it and got this cubic, and they had to get where the original function is increasing and decreasing. To my eyes, they got the right answer, that it's decreasing up until x equals -1, then increasing thereafter. But the book says it's increasing, decreasing, then increasing again, and I think it's wrong. So I'm trying to tell this person that they're right. Right, whether we have x plus 1, x minus 1 squared, or plus 2 times x minus 2 squared, or whatever similar example. That's just the function you get. You derive, and you can't control that. Okay, so Sunnytab also agrees that it's an error. If you took the square root of one of them, that's a different function now. It's not the derivative of the original f of x. Yeah, the professor must have made a mistake, like Sunnytab said. Okay, I was on Learn Math. Let me erase this on the board. Come on. Hey. Okay, good enough. See, where was I here? I was there. Ooh, modulo with cryptography? I can't really help with that. Get some, like, what's it called? Modulo arithmetic or whatever? That gets really crazy. I only ever had to do it a tiny bit, and I never understood it. For modulo algebra, maybe. Um, all right, not too much else on the subreddit. Let's go on to Ask Math. Is our system for time? Oh yeah, and like it's mod 60 for like minutes and seconds. But like, oh yeah. I also thought about it being like a base 12 or like a base 60 system, but even though that's not really like true because you don't have your own symbols. I guess mod is a better way of explaining that. Um, it just comes to like when you actually go to apply it to a problem, though, I still like have a really hard time understanding it. A circular rubber band being squeezed from the topmost and bottommost points until it becomes flat. Every shape, not including the flat line in the circle, should be an ellipse with the same circumference as the starting circle. That's interesting. How do you transform an ellipse while keeping its circumference constant? What is the circumference of an ellipse? Pi AB? Oh. Oh, for area? Wow, that's not as simple as I thought. Says pi times a plus b as an approximation. I didn't know that ellipses were that hard. You can use calculus for it, though. Well, that makes it a lot harder to answer this person's question, actually. I assumed it'd just be a simple formula. It's a whole class of integrals called elliptic integrals that make it hard. Ooh, okay. Um, I don't know what to tell this person now, because it's just not that easy to calculate. And they're trying to do it for the sake of a 2D animation. Like, do they need the actual equation of it, or I feel like this would be program dependent for how they'd actually want to implement it. So, I mean, we could explain how. I feel like it's gonna be more of an experimentation thing. So let's just look up equation of an ellipse, because maybe the best way is just going to manipulate A and B and look for taking away from, I guess, A or whatever the vertical is and increasing B. And it's probably going to be something that's easier done experimentally to make it look about right, rather than trying to do something exactly mathematically correct or correctly. Um, so yeah, in this case, I guess I'd want this first one, 8.2.1. No, I mean, I think I'll still try posting something, unless someone else has already answered it. I'm not familiar with animation. But calculating the perimeter of an ellipse is not easy. There are approximation formulas. Equation of an ellipse. That's a long link. Jeez. Oh, it's because I don't need all this. I think I can get rid of that part. And does this link work? Okay, yeah. Oh my god, please. There. For this case, well, I mean, I'm not gonna. If you know the equation of an ellipse, you would basically want to manipulate the values for A and B gradually manipulate the values for A and B, or gradually increase A and decrease B. It's something until you get nearly a flat line. Since the perimeter is hard to calculate, probably here to eyeball it, to eyeball it, rather than trying to. I mean, I don't know if I should even go that far. You'd want to start to gradually increase. I need to. I should explain. You would basically want to start with A equals B, a circle with radius A squared, and then gradually increase A and decrease B until you get a nearly flat line. Which is a circle with radius A squared. Okay, let's see if that helps them. Because, oh no, my link didn't work. Because there's parentheses inside the link. Do I need that? Does this work now? Who puts parentheses in their URLs, man? Okay, it works now. Oh, math competition problem? What's happening this? Or with this? Actually, I don't know why I'm playing on a competition problem. I already feel out of my depth and I haven't even looked at what the problem is yet. A equals 0, 0, B equals 1, 2, C equals 3, 3, D equals 4, 0. Watch out, all the ABCDs fit into 3 areas kind of equal area pieces by line passing through A. The line intersects CD. Point P over Q, R over S. look at solution 2, so that's what their question is on. At the point where the altitude from E to AD be labeled F. Okay. Following the steps above, you can find the height of triangle ADE is 15 over 8. What's steps from above? Oh, 15. Wait, they give 3 different ways to find the area of quadrilateral ABCD. I guess you would be able to find the area. I haven't heard of Pick's theorem or Shoelace theorem, and I don't see what the third way is. At least not yet, but I mean, my only way of doing this would be able to divide it up with triangles and squares. But actually, I mean, we don't need to know like how they get that altitude though, or the height. X and 4 minus x. Four minus x is the segment from point F to D. How do you know that's... Oh, because the entire length is 4. You just know that. Okay, okay. Then by Pythagorean theorem, well... How to run for bio, then you're missing a geometry problem. Yeah, it's a geometry competition problem too. The setup to it is pretty simple though, Jed. You can basically a quadrilateral with these 4 points, and the line going through it cuts the area in half. And they're just asking to explain the solution to the problem. Hey, is first again? Probably not. I'm not really good at competition math. I don't normally look at them, but someone happened to be asking about one in a homework help forum, so I want to at least see if I could understand it. I'm no good at competition math though. But yeah, basically the goal is to find where the point E intersects CD, or basically find the point E and it intersects CD. And so they work out what the height is, and they say at the very end here, Pythagorean theorem to get the like how far its x coordinate basically. Ooh, and thanks for the follow. So do we get the length of AE somewhere up in solution 1? That could be helpful. Line CD can be expressed as y equals minus 3x plus 12. Oh, they do it like a... Oh, that seems like a much easier way. You find the equation for this line, and you find what its y value is there. But we're talking about Pythagorean theorem, so let's see if we can figure out the Pythagorean theorem for this situation. So I don't think we know what either hypotenuses are. I looked very clever and congenial, so you dropped a follow. I appreciate it. Thank you. Me copy down the lower part of the drawing and see if we can work out what they mean by Pythagorean theorem. A, E, D, and F. We have x, 4 minus x, and that is 15 over 8. So if we Pythagorean theorem on the Ellipse triangle, AE squared equals x squared plus 225 over 64. On the right triangle, we get DE squared equals 225 over 64 plus 4 minus x squared. So that's actually, we have too many unknowns. That's two equations and 3 unknowns. AFE is similar to EFD. Really? I don't know how we know that. Oh, okay. I can bring up the original. Oh. We need to make another realization here for what I just put there to work. Yeah, I don't think we necessarily know that they're similar. X times x minus 4 equals 15 over 8. Um, yeah, Jed, the person basically asking about the part they highlighted down there, like how do they use the Pythagorean theorem to find x? I'm not sure what you're talking about, Spurskin. I don't know what the stars mean there. I much prefer the way they did it in solution 1, because that just makes more sense to me. Um, area of AED is equal to area of AED. Um, you could. The area of the entire thing is 15 over 2, so the area of just the lower triangle is 15 over 4. So we do know the total area. Here, the price of the triangle edge where the height h squared is equal to dk. Really? I've never heard of that. You know what the name of that is? You might be right. I just haven't heard of that. Um, would that give us the same? So x is supposed to be 27 over 8. Let's see if what you said gives us that, Jed. That's an interesting way to do it too. It's not the way that the um solution key said to do it, but I'm interested to see if that works too. The Euclid relation. Let me. I'm interested to see if uh what you get. Why doesn't this solve for x? Expanded form, true. Solve for x. Okay, that's cool. I didn't want to know what x was. The x's cancel out. Oh, okay, okay. That's why it's true. Euclid relation. Euro just seems a little bit weird to me. It's first game with like going to like Facebook photos, so. Triangle height. Equals edge times edge, maybe. Aaron's formula? I've heard of that. Let me see Aaron's formula. Oh no, that is a little bit different. But I mean, either way, the solution's to do Pythagorean theorem, so I want to do it with that. Like, they're not asking about some third way to do it. They want to know the Pythagorean theorem way to do it. The thing is, if we know the length of one of these segments, then we wouldn't need the Pythagorean theorem, would we? Here. Oh, okay. Sorry about the noise.
Dikten 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 dik dikten dik dikten dikten dik. Dikten dik dikten dik. Yakaladık. C'nin karesi.
I'm digging the musical math. But okay. That looks like the word theorem. What happens if I Google this? I wonder if it'll translate it. Okay, fine. It's fine. That's still an interesting thing to see. I know it's still like I don't know how you're supposed to put the Pythagorean theorem though specifically. In Turkey, we must memorize every theorem. Oh, you're from Turkey. Um, that sucks. You have to memorize everything. Yeah, I definitely have never. I don't think I've seen that before. Pythagorean with distance formula? Maybe? Does it say, or can we show that AED is right? I don't think we know that AED is right. I don't see an easy way to show that. Man, this feels like it should be a simple question. So this is funny because we know the area of the triangle, we know the height, but we still actually can't find a single side of it. There must be some kind of clue in the first part, I feel like. Or maybe they're talking about Pythagorean theorem on something like we formed some other right triangle. I don't know. Let's see if has someone else answered this one? No? I do have a response. I'm gonna look up what the person said here, but I'm so curious about like all we know are the points of A, B, C, and D. We know this height. We know X must be between 3 and 4. You know the Y coordinate of E. Precedence of AE in terms of X. Wasn't that just this? That's going to end up being the Pythagorean theorem that I just said, isn't it? I wish that we could relate the sides and proportions somehow, but I don't know how to do that. Like if we relate AE to ED or something, that would be perfect. Let's go with what this person said though, because I could probably actually answer this one. um, okay, good. Okay, so yeah, for this part of their question, um, hey Central, the answer is 5. Thank you. I assume you had been playing Azalea. How was that? X just gets multiplied to the numerator. And you went into the bunker? Nice. Like, well, what was in there? In the denominator. And the denominator gets left alone. It's huge. Oh, so those like the giant thing of rocks really was the roof. like the entire way. To think about it is that x equals x over 1, where the x gets multiplied with the numerator, and the 1 on the bottom is multiplied with the denominator. What's that? This one, it's gonna bother me. Got a plate in AK 101. You were with Luke Light. He had an AUG AX. Oh my god, and pox grenades. That sounds perfect. Do you get the key card off a heli crash? Oh my god, just I'm just imagining shit showing up to Sadra with that stuff. That would feel unfair, but also really fun. Because we were just gonna spawn and come right back. You're getting off Luke breaks your leg. It's challenge mode, you know? Get them off Captain Zombies. Oh, yeah, I barely remember seeing Captain Zombies. I guess there's only a couple of military spots there, though, as it is currently. So that purple keycard must lead somewhere else then, from the heli crash. One of the other asterisks is. That's cool though. Okay, there's a box that needs a different keycard. Oh, okay. I really hope they do more playtests for Azalea. Because like just for the weekend is not enough for me. It seems like other people are really liking it too, so hopefully the person gets some incentive to keep on developing it. I don't know, it's only gonna go until 2 in the afternoon for my like by my time. So that doesn't really give time for like that long of a play session. I've been working on this for ages. I mean, it seems like it wasn't perfect, but it was really good. Like way better than like what I would have made. Stupid question for me. I love stupid questions. And sorry, while I've been talking about video games, I've still been thinking about this geometry problem. I'm just like, where I don't know. Once you get the y coordinate, why not shoelace to get the x coordinate for ABC? I had never seen shoelace before. What? The area is half of 1 times 3 minus 2 times 3. Oh, we do the same thing just with a smaller thing? Just with the smaller shape? And you have a variable in the middle instead? Oh, what a weird theorem. I guess I see why it's called shoelace, because it like interlaces. So I mean, it's still a Pythagorean theorem, but this seems valid too, because you just have like you know what the area is, and then you know you're just gonna leave like one of the y's as a y, or an x as an x rather. I might just need to move on from this problem because I really don't see it. But I think that's also perfectly fine, Jed. you would have to find some way to relate, or I would think you'd have to find some way to relate two sides of the triangle proportionally. I mean, can you look at the entire bigger triangle? I don't think you can make any like statements about them though still. I don't know. Maybe I should just move on. Or can you use like trig functions? I don't know. We can look for a different one. I'll still have that up, but actually wait, let me get a different tab. Keep the problem up in case someone comes up with something. But for now, I'm just gonna look for a new math question. You want to explain how to solve this? Find a and b so that the function this is both continuous and differentiable. Ooh, a and b. Okay, so posing for anyone joining. Oh yeah, there you go, Jed. Thank you. What? That is not what I did, OBS. I'm going to erase this on the board because I don't think it's that helpful. Okay. Any day you learn your... Yeah, no, I don't mind you doing that, Jed. Any day you learn something new is a good day. Yeah, I mean, unless you learn something that's like disturbing that you would rather not know. 5x cubed minus 3x squared plus 3 when x is less than -2. We have ax plus b when x is greater than or equal to -2. So we need to find a and b to make this continuous and differentiable. So both, for it to be continuous, these two functions have to equal each other at x equals -2. For it to be differentiable, I believe the derivatives also have to be equal at x equals -2. So first, I think it's helpful to find out what f of -2 is. Or, well, rather, not f of -2, but what this function is for -2. Because f is technically defined with the line when it equals -2, so we'll just plug, I want to say plug -2 into the top function where we know everything. 2 squared plus 3. All right, -2 cubed is -8 times 5 is -40. Minus 4 times 3 is 12. Wait, -40 minus 12 is 28. No, oh my God. I'm not doing mental math. -40 minus 12 plus 3. There we go. I was messing that up horribly. -52 plus 3 is -49. My 3 doesn't look like a 3. You're right. That looks only marginally better. 3, there. Okay, you also got -49. Okay, good. So we know that ax, or f of negative 2 is equal to a of negative 2 plus b equals negative 49. But we can't solve for a and b quite yet. We need more information. So let's go and find out what the derivative of the top function is. 5x cubed minus 3x squared plus 3, parentheses prime. That is 15x squared minus 6x, and that becomes 0. Okay, now we want to plug negative 2 into there. (15 times negative 2 squared minus 6 times negative 2). Mental math this time. Positive 4 times 15 is 60, plus 12 is 72. That's a steep slope. Okay, you also got 72. Thank you, Jed. Make sure things are still showing up on stream. Okay. So we also know that that should equal 72 at x equals negative 2. F prime of negative 2 going to be just a, because b derives to 0, ax derives to a, is equal to 72. So a equals 72, we can bring that up here, and I'm going to write it down here just to be confusing. So 72 times negative 2 plus b is equal to negative 49. I am going to do this mental math, and I'm going to get it wrong. Mark my words. 144 negative, so you add it to both sides. 144 minus 49. Don't tell me. I need to do this. 95? Positive? 95? Hell yeah. Thank you, Jed. Hey, Mitra, be slick. So I think that's the values for A and B right there, 72 and 95. That's a very weird looking line. I want to graph this to make sure it covers the... oh, yeah. Actually, I'm just about to expand it anyway. It just said f prime of negative 2 there. I need to be way better about browser covering things, though. So I do want to plot both these, because that's a very, like, steep line. 5x cubed just call me Slick, but your name is like your truck without a CK in truck. True? Okay, I'm too slow for that, but I'll call you Slick. I'm sorry, because I'm sure that's just me being stupid. 72x. Mitra. Oh, I'm so sorry. Mitra, not Mitra. I see. See, I told you I'm stupid. Wait, Mitra? Wait, I said Mitra the first time, and it's supposed to be Mitra? Okay. I'm double stupid, see? Okay. I see, my truck minus the... okay. Now, I see to have explained to me many times. My truck, be Slick. But I'll just call you Slick anyway, because my feeble brain can handle that. Mitra. Okay. Okay, so it actually does look pretty. I mean, ugh, I wish I could change the view on Wolfram. I mean, I'm sure you can. I'm just too lazy. It's on Desmos. The graph looks like it makes sense though. Yeah, but with Desmos, I can just like drag it around. It's much easier. Mitra. my best. I mean, I feel bad because I butchered a lot of people's names, but like, I know it's hard to get everyone's right. And then like I realize it later that night after I'm done streaming, it's like, oh, I totally butchered that person's name. I feel bad. Name's complex. Thank you for understanding. We're saying x equals -2. Let's follow wow. Okay, so it makes sense that oops, the line's going to be this steep. They cross over right about there. I mean, it's hard to tell exactly, but they do intersect at the right point, and their derivative does seem to be about the same. So I think this answer makes sense, even though the numbers are very odd. See if we got beaten to the punch? No? Okay. Oh, did you do it with Wolfram? You guys are good at math. I'm trashy. Did you switch A and B, Jed? No? Wait, did I switch A and B? No? Why does this... No, stop it. Why does it look so different? So on Desmos, it's really steep. On this one, it's not steep at all. They both look right, though. 5x cubed minus 3x squared plus 3. Oh, ha! That'll do it. Thank you, Jed. I'm not that good at, or at least I'm not that good at math. I have to Google most of the things that I look at. I do enjoy it though. Or I have to like ask chat for help. For the function be continuous, the values for each must equal each other at x equals -2, and for it to be differentiable, the derivatives must also be equal at x equals -2. Gotta do math 2, so yay. Oh, awesome. What math class are you in? Or are you just doing math for fun? Or like, you know, self-study? So let's give them like the setup for this and then leave it at that. You're freshman, so algebra 1. Oh, okay, nice. Thanks for the follow. For being continuous. Wait, continuous. We know that 5 times -2 cubed minus, I'm a goofy goob. I'll own it, yeah. I'm a goofy goober. Equals A times -2 plus B. I'm the goofiest goober of math. Hell yeah. That needs to be my stream tag. We can do a similar equating, or we can derive, or we can, I guess we can also derive each one, plug in x equals -2 and equate them to get another equation that will help solve for A and B. Gonna go work on your novel? All right, thanks for hanging out. Equate them to get another equation. I don't like that phrasing, but I don't know how else to say it. I also want to just get an answer posted before someone else does it. Okay. I do have a new response. Makes a lot of sense. Thanks. Okay, good. Glad it helped. Ask math. Explain how I find what a is equal to. Let's see. Oh, we got limit definition of a derivative here. F of x is -8 minus 4 root x, and the expression can be written in the form that. Can it? Yeah, probably rationalize the numerator or something. Probably. I'm not sure exactly what's up with this. Let's try plugging things in and seeing what happens. Actually, let me make that a bit smaller because I know I'm gonna not notice when my math's being covered up by it. Oop. So f of x is -8 minus 4 root x, and they want us to plug it into the limit definition of a derivative f of x over h equals, so f of x plus h is -8 minus 4 root x plus h. God, this is sloppy. Let me write that. -8 minus 4 root x plus h minus f of x. -8 minus 4 root x over h. Let's combine some like terms. Okay, I'm not covering up my work yet. -8 minus -8 is 0. Minus -4 root x is plus 4 root x. Minus 4 root x plus h over h. How do we get a constant in front of the x and the h? This just seems like weird algebraic manipulations, but I guess let's rationalize it, or let's multiply it by the square roots. I assume this must be how you take the limit. Oh, I guess, yeah, if you try to take the limit as h goes to 0 right now, it's, you know, you can't do it easily. So let's multiply by the conjugate. This is a very weird way to basically make you get the limit, but I guess it's making you practice the algebraic manipulations. Okay, so I can start my work there without it being covered. So we get 16x from 4 root x times 4 root x minus 16x plus h. Okay. Over. I'll keep the h on the outside actually, because I see where this is going now. It's 4 root x plus h. Close parentheses. Come down a line. So we get 16x minus 16x, so that's 0. We still have minus 16h over h, 4 root x plus 4 root x plus h. So now the h's will cancel. And the 16 will cancel the factors of 4. So we get -4 over root x plus root x plus h. Oh, and then when you take the limit as h goes to 0, that will work. Okay. So they actually got b equals 1, c equals 1. But they're confused on how to find a, which if they got c and b and c the way that I got them, it should be clear what a is, but they must have done it a different way. In theory, you well, or I guess constants. When you plug in f of x, you get, it's gonna be a little bit of pain to write, but I think it's worth it. -8 minus 4 square root x plus h minus -8 minus square root x divided by h, or over h. That's not that much of a pain. I don't know why I'm complaining. From there, you multiply the top and bottom by the conjugate. I think conjugate is the right word. Actually, I'm going to say you multiply by the conjugate. Or from there, you simplify and multiply by the conjugate of the result. So I multiply by 4 square roots x plus 4 square root x plus h over the same thing. It's a result that matches the format required by the problem. Okay. Hope that helps the person. Look at this one. The first 3 log properties thing kind of scares me because I don't know how they're numbered, but given log of 2 is a, what is log of 1 over 40? 40 is not a power of 2. Do you have to split it up into 36? No, wait, 36 isn't power of 2 either, is it? 32 is a power of 2. 32 plus 8? And is there is a log identity for addition inside the logs? Or am I getting it mixed up? Who University of Washington has for this? Oh, there isn't for addition inside the log. It's for multiplication inside the log. Right, Jed. It's that one right there. But they don't have a power of 2 inside the log. They have 40. So I was hoping you could split it up with addition into 32 and 8, which are powers of 2, but once you get addition inside the log, you can't do anything with that. Right. So I mean, if you look at the factorization of 40, you have a 2 cubed, and then you have the other factors, whatever those are. Oh, just a 5. 2 cubed times 5. So you could have 2 to the negative 3, 5 to the negative 1. But the 5 to the negative 1, I don't think you can do anything with that. You're kind of stuck with it. You could separate it out to its own log, because that is multiplication. Are you allowed to do that? Maybe you can. It's not going to be only in terms of a, but if you're allowed to have a log 5, log of 2 is a. Log of 1 over 40 is log of 1 over 2 cubed times 5, which is log of 2 to the negative 3 times 5 to the negative 1. So you can split it up into addition. Log of 2 to negative 3 plus log of 5 to negative 1. Then bring the exponents outside. Negative 3 log 2 minus log 5. And then log 2 is a, so negative 3a minus log 5. I don't like that there's a log 5. That seems like the most that we can do with that. I guess this is, I guess I'll do this. I mean, you could try and get like two, like what, it'd be irrational, but I wonder, 2 to what power equals 5. That seems like it's gonna be way too much. I was just looking at the second one, which almost seems like much of an algebra problem as anything else. Which I guess this is algebra, but like not willing to use log identity on the first step, and then you don't need it. So we'll give them hints for all this. They didn't say what they didn't really post their attempt or anything like that. But looking at I'll start it there. Log of x squared minus log of y over log x to the 4th minus log y squared, right? Right. We're going to use the same exponent rule on the 3 logs that have powers. 2 log x minus log y over 4 log x minus 2 log y, log y. And then we factor 2 out from the bottom, and we get a nice cancellation. And so actually you just end up with 1/2, don't you? Okay. And then for the third one, 2 log of x cubed minus 3 log x to the 4. Log, ooh, the denominator is going to get a little tricky. Let's try it. 2 log x cubed minus 3 log x to the 4th. So the numerator looks simple enough, just like all the other ones we've been doing. The denominator, though, 2 log xy squared, or no, wait, 2 log, no, just log xy squared. Minus 2 log xy. So on top, let's do the same thing with the exponent rule. 6 log x minus 12 log x over. Here we're going to split it up we're going to split the multiplication up into addition and use the same exponent power on the y. log x plus 2 log y minus 2 log x minus 2 log y. That minus 2 needs to be multiplied to both of those logs. On top, we just get minus 6 log x. On the bottom, plus 2 log y minus 2 log y, that becomes 0. Log x minus 2 log x is minus log x. So we just get negative 6, or positive 6. Okay. Just give me a minute to type out this message. Um, okay, sorry about that. So I'm going to give them hints for all these because they didn't post their attempt. Oops. Let me remember to do that. There we go. The first one, factors of 40, and you will find that 2 is involved. Or actually, I can be a bit more specific. Of 40, actually, first one, 40 equals 2 cubed times 5. So 1 over 40 is equal to 2 to the negative 3 times 5 to the negative 1. So log of 1 over 40 equals log of 2 to the negative 3 times 5 to the negative 1. From there, use the multiplication identity to split it up into 2 logs added together. Then use the exponent rule to bring the exponents down as coefficients. Replace any remaining log of 2, or replace the remaining log with 2 of a. The a. Second one, log of x squared minus log y is equal to 2 log x minus log y. The bottom similarly becomes 4 log x minus 2 log y. Try factoring out 2 from the bottom and looking for cancellations. For the third one, that's for the second, I would start with, or use nearly the same approach. I would start the multiplication and on the bottom logs. We get 4 logs added together. Then bring the exponents down and look for cancellations. Okay. So I'll just keep giving hints because they didn't post their attempt, but hopefully that gets them started.